This is going to be a video demonstrating the Fermi Energy surface. For the entirety of this clip, I'm going to be using this cardboard box as a metaphor for the surfaces, the top representing the conduction band and the bottom representing the valence band of electrons. Now I'm going to demonstrate electron conduction in metals. This occurs when the conduction band is almost completely empty, save for a few charges. This makes it so that when the material is exposed to a potential gradient, the electrons can flow, skipping from pocket to pocket until they bottom out in the gradient. Next, we'll demonstrate hole conduction in metals. This occurs when the conduction band is almost completely full, save for a couple pockets, of electrons. This is actually very similar to electron conduction in that electrons are traveling across a gradient. The difference here being that it's actually easier to follow the path of the gap instead of the electrons themselves. Notice, however, the interesting consequence of following this quasi-particle. In fact, this quasi-particle travels up electron gradients. This is actually why physicists represent holes as having a negative mass. They simply have an acceleration in the opposite direction. Last, I'll be explaining the class of insulators with the inner category of semiconductors. Notice that in this scenario, the conduction band is totally empty and the valence band is totally full. This means that conduction is nigh impossible, except in the specific scenarios in which the gap energy is small enough that you can easily traverse it. Notice that this generates both a charge in the conduction band and a hole, or a positive charge, in the valence band. Both of these created carriers can now conduct across the material.